Okay, thanks for coming in and watching my video here. We're going to be doing day 2 rationals to help you there. And here we go. So we'll start off number 1. So basically we're going to be doing denominators that are more than 1. So for example, x plus 1 instead of just x. Still works pretty easy, pretty the same way there. But don't forget to find the exclusions too. I noticed that this wasn't on your worksheet. If this is year 2015, if it's 2016, then it probably is on your worksheet. So it wasn't on your worksheet there, but you do need to do it, so include the exclusions. So don't forget to list those for a point. So for example, number 1 is just going to be x plus, so 4 over x plus 1 plus 3 over x plus 1 is just going to be x plus 1 once in the bottom. And then we're just going to put 4 plus 3 on the top. So combine the tops. And so when we add those together, we'll just get 7 over x plus 1. So that's your answer for number 1. Not too hard there. And the exclusion, we do need to go back and make sure from the original and from our problem there. So the exclusion is x can't equal, so we set those equal to 0, and we minus 1 to both sides. So x can't equal a negative 1. Because if it is a negative 1, then negative 1 plus 1 is 0, and we can't have 0 in the bottom in the denominator. Okay, so the exclusion is x can equal negative 1 for 1 point, and 7 over x plus 1 for 1 point. So there's 2 points for each problem there. So try number 2 out, see how you do there. We'll try a different one here that has a different denominator. So for example, let's try number 4. So when we have a different denominator, we actually have to multiply both sides by the different denominator. So even though I do have an x plus 5 there, I am missing an x plus 1. So if I multiply x plus 1 in the bottom and I also do it in the top, that'll help us combine our fractions, our rational fractions. What's this side missing? That's right, this side is missing the x plus 5. So we'll multiply x plus 5 on the bottom as well as the top. And then we can multiply those numbers in there. So let's write the whole thing over. X plus 5 times x plus 1. Since we have the same denominator, we can write it just once on the bottom. And then we're going to distribute the 2 through. So 2 times x is 2x. And then 2 times plus 5, positive 5, is a 10. Because we multiplied the top and bottom by x plus 5. Now, tricky part here, that negative actually gets distributed through as well. So we're actually going to change that to a negative, and you could change that to a positive if you wanted to. But we're going to take that negative with us and multiply it through. So we get a minus 3x, and the negative 3 times 1 is a negative 3. Cool. Now to finish that off there, we're going to add like terms. So the 2x and the negative 3x becomes the negative 1x. And then the 10 minus 3 is a 7. So then we get negative 1x, or negative x, plus 7 all over x plus 5 times x plus 1. And so the x plus 7 doesn't match in the bottom, so we can't cancel those out at all. We also can't cancel the x's, because they're connected like a you-know-what, cool mother's nourishment, weird. Yeah, so those are connected, so we can't cancel the x's there at all. So that's just our answer. Now don't forget your exclusions, because that is part of the answer there. So our exclusions, let's see here. So doesn't equal 0, because we don't want it to equal 0, because that would be undefined. So that means that negative 1 will be bad, right? Negative 1 would be bad there. Because negative 1 plus 1 is 0, so x can't equal negative 1, as well as a negative 5 would be bad too. So x can't equal negative 1, x can't equal negative 5. So there's our answer there for number 4. See if there's another one we can help you on there. Not too bad there, not too bad. Let's see. So let's see here. Could possibly see factoring involved, maybe, with number 9 or 10. Let's see here. Let's try number 9. So number 9 is missing the x plus 5 on this side. And then on this side, it's missing the, what? It's missing the x minus 5 on this side. So we'll multiply those together with their own individual parentheses. So that means we can write the whole thing over, x minus 5 times x plus 5 on the bottom. And then multiply it through. So we get 2x times x is 2x squared. And 2x times negative 5 is negative 10x. Over here, x times x is x. Oh, wait a second. So don't forget that negative with the x. So negative x times x is a negative x squared. And then negative x times 5 is a negative 5x. Cool. So then, I can already write my exclusions. X can equal 5 and negative 5, or plus or minus 5 if you want to write it that way. So there's one answer for 1 point. Nailed it. Now, to finish simplifying this, we have 2x squared with a negative 1x squared is just 1x squared. And then negative 10x with a negative 5x is a negative 15x. Okay, making sure we did that right there so far. Okay, so I guess we could factor out an x, but I don't know if that would help us at all. We could factor out an x and get x minus 15, but I don't think that would cancel with the x minus 5 or the x plus 5 in the bottom. So I think we're good. I think we're golden there. I think that's just the answer because it can't, but you do want to check on these to see, because maybe like if this was just a 5, then we could have canceled those two. But it's not a 5, and so we can't cancel them. So just double check there. So there's your answer there. Yeah, like maybe number 10, maybe something cancels out to reduce it there maybe. Let's see, on the back side here, looks like we have single factoring going on there with like number 12, for example. So we'll pull out a 2, leaving us with divide by 2, divide by 2. So leaving us with the 12 divided by 6. Cool. And so, so the only thing missing on this side is just a 2, right? So if we multiply top and bottom by 2, we get, so it's always good to factor it out. Single factoring, double factoring. Always good to factor it out to see what you're missing so you don't have to do too much multiplication to the top and bottom, to the left and right. Okay, so let's see. So on the left, we already had everything. On the right, we were missing a 2, so we multiplied it through. So then we just bring the 6 down. And then 2 times 5 is 10. So we have minus 10. And then that's, let's see here, that's supposed to be an x there. And then 6 minus 10 is a negative 4. So we get negative 4 over 2 times x plus 6. Now, because of multiplication, we can actually divide the top and bottom by 2. So that's not the correct answer what we have right now. We do need to divide this one by 2 and divide this whole thing by 2. And because of multiplication that's between those two, we can actually cancel those out. So 2 divided by 2 is just 1, or it just goes away. And then negative 4 divided by 2 is a negative 2. So negative 2 over x plus 6 is our final answer, with the exclusion of, let's see, so what would be a problem right there? A negative 6 would make the whole thing 0. So with the exclusion of, x can't equal negative 6, because that would be definitely a problem there. So don't forget to reduce. Like I was saying, some of these you can reduce, so make sure to do that. I did have a request, especially for, to help you, this factors into x plus 3 and x minus 3, just to help you there in 14. That's a special factoring. Don't forget to do those. 15. Looks like there's x squared plus 1. Looks like there's 2 of them. because that's to the second power. So that means it's x squared plus 1 times x squared plus 1. So we write it out twice. That means this side is just missing a, what do you think, Carly? That's it, you guessed it. I bet you did anyways. It's missing an x squared plus 1. Nice. So if we multiply to the bottom, now the bottoms match, the denominators match. So if we multiply to the bottom, you also have to multiply it to the top. Cool. So then we go ahead and just write x squared plus 1 times x squared plus 1 on the bottom. Now they're not a minus 1, it's a plus 1, so they can't factor out anymore. And then we're, sorry guys, just making a video. Yeah. Come check with me in a bit or after school. So then, let's see here. So then we have, let's see. Okay, so the top, so we already have the minus 4x squared minus 5. So we could multiply that through already. So that just means a negative 4x squared and then a positive 5 is what we write down. So that side's done. This side we're going to have to multiply 3x with the x squared. So we get 3x cubed, and then 3x with the 1 is just a positive 3x. And then we have the minus 4x squared and the minus a minus 5, which is a positive 5. Cool. So then, let's see here. I can already tell what our exclusion possibly is. Can you? So the exclusion is a I don't think there's any, is there? A negative 1 would be squared to make it positive, so that would never happen. I guess just a imaginary I could probably be it. What do you mean, Mr. Newell? We'll come back to that in a second. Okay, so we'll finish this off here, number 17. So we need to collect like terms, and really they're all there unless that can factor out more, which it might be able to by grouping, but first let's put them all in order. So we're going to do a 3x cubed plus 3x, no, 3x cubed, what's the next power? Is it a 2? Yeah, an x squared. So 3x cubed minus 4x squared. And then we have a plus 3x and then a plus 5. And then we're going to put that all over x squared plus 1 times x squared plus 1. But I'm wondering if that could factor out more, actually. Let's see. Looks like we could factor out maybe. And let's see. Maybe pull out an x squared here. So if we pulled out an x squared, we would have a 3x minus 4. And then here, you couldn't really pull anything out. Maybe just a 1. So plus 1. So divide by 1, multiply by 1. And you just get 3x plus 5. That sounds silly. Let's see. But, so I guess, yeah, that minus 4 is what's throwing us off there. That minus 4x squared. Because if it had been a plus 5, we could have actually canceled out more. But it's a minus 4, so we can't cancel out anymore. Okay, so the final answer for 17 then is just it reordered. So 3x cubed minus 4x squared. We did try to simplify more, but we couldn't there. And so 4x squared. So we had a minus 4x squared there. Next was plus 3x plus 5. Cool. All divided by. And you could write it twice if you wanted to, or you could just write x squared plus 1 all squared again to finish off your answer. Now the exclusion, you have to set the bottom not equal to 0. So x squared plus 1, you could even say all squared if you wanted to, not equal to 0. So I'd have to square root both sides. So we get x squared plus 1 is not equal to 0 still. And then minus 1 to the other side, so we get x squared can't equal a negative 1. And then if you square root that, you actually get a negative 1 in there. So I guess really it would be x can't equal plus or minus the square root of negative 1. And the square root of negative 1 is just I, just the letter I. So if you want to put that down as your answer, or put none. I'll double check here just to make sure, and you can watch me do this. So just double check here on our answer key here. There we go. And so let's see how we did there on that last one. There we go. Okay, so there we go. So there's our answer for number 17. And we didn't put any exclusions, but we did get it right there, so that's good. Okay, so that'll help you there. Thanks for watching the video. And hopefully you enjoyed that funny video with my rodeo course somewhere in there. And thanks for watching, and this is due next time. And thanks for working hard. And you take care. Bye for now.